Hi, welcome back to Become a CSS Superhero with Stylus. In this lesson, you'll be learning how to create a PX to REM converter variable. So, coding your layouts to work with rem values rather than pixel values allows them to stay flexible and scalable. But it's a lot easier to conceptualize your designs in pixels, especially if you come from a background where you might be used to designing fixed width sites. For example, it's a lot easier to think about a space being 200 pixels wide than it is to think about it being 12.5 rems wide. It's just a lot more of a natural way to think of things. So what happens though if you want to make sure that your designs stay flexible and scalable, but it's a bit painful, it's a bit time consuming to perform these calculations all the time to figure out what the actual rem value that you should be using ought to be. Now this is where Stylus's ability to perform mathematics for you and its ability to hold variables comes in really, really handy. You can set up a calculation once that you can use every time you need to convert a pixel value into a rem value. And that's what you'll be learning here. Now, before we get into actually creating that variable and the pixel to rem calculation, I want to go through a couple of points on why rems are important and why you want to use them. And we'll have a bit of a look at how rem values compare to pixel values and em values. On the right side of the screen here, you'll see three boxes. Now, each of these three boxes right now is 160 pixels wide by 160 pixels square. But this box is controlled by this class here, and you can see that it's using actual fixed pixel dimensions. The box in the middle is controlled by rem units, and that's using these values here, 10 rem by 10 rem. And the third box is controlled by em values. So that's these values here, 10em by 10em. Now with all things set to default values in the browser itself, and with no extra code added beyond what you're seeing here, each one of these will appear to be 160 pixels square. However, when those default settings in the browser change, which they will often do out in the wild, then the appearance of these boxes will also start to exhibit different behaviors. Now let's take a look at that. Now I'm going to open up the Firefox preferences, and you'll see here we have the base font size, like the default font size set in the browser. And people will often change this default font size. They'll change it because they may have a little difficulty reading text because it's usually too small for them, or they may change it because they are using the browser on a large display like a television. There's all kinds of different reasons why a person might change that base font size. I actually delve quite deeply into that subject in my course, Bomb-Proof Web Design. So if you're interested in learning more about why people might be changing these default settings, you can check that course out too. Let's have a look at what actually happens when we change this number. So we'll go from 16, let's say, up to 20. Now you can see immediately this box has not changed in size. This is the one using the fixed pixel width and height values. These two boxes, however, have both changed. Rem units and em units are both flexible, scalable units. And what this means is if a person has increased the font size, they're not going to end up with a layout that hasn't also increased in size. If somebody has increased the font size and nothing else changes, they're going to end up with very cramped text that doesn't have a nice flow of how many words there are per line, and everything's going to look really squashed up and nasty. So you want to make sure that you allow people to change that default font size and keep your layout and the look of your designs intact. You might be wondering, okay, then both of the boxes on the right have scaled up, the rem and the em box, so why not just use ems all the time? Well, the difference between rems and ems is that an em value will be affected by the font size of the element that it's used within. I'll show you what I'm talking about. First, we'll just reset this back down to 16 pixels. Okay, so now if I change the font size of the rems based box, we'll scale it up to 1.2 ems, so that'll be 120% of the original font size. Now you can see that the em box has increased in size. It has also increased by 120% along with the font size setting for that box. But if we do the same thing on the rems based box, nothing changes but the actual font size itself. Now this means that rems are better for container elements. They're better for the parts of your layout that are integral to how the whole thing works together. The way rems work are they're based on the font size that's applied to the HTML element rather than the font size of the actual element that you're working within. And the most common default font size, that is the font size that is applied to the HTML element, is 16 pixels. Again, in my bomb-proof web design course, I talk about why it's important to leave the base font size alone. Don't try to manipulate it unless there's a good reason to. So generally speaking, default browser settings on most devices will have fonts at 16 pixels. Now, if you then want to figure out if you have a pixel value that you want to create the equivalent for, you will need to do a little bit of maths. Now, in this example here, I've used a nice round number of 160 because, we have the base value of 16 pixels. Now, if I want to create a 160 pixel wide box and I know that the base font size is 16, I then need to use a 10 rem or 10 em value. And that's what we've done here. Now, if you want to reverse engineer that, then you have to just do the sum backwards. So we know that 10 rems times 16 is 160. If we wanted to figure that out the other way, you want to end up with 160, then you would say 160 pixels divided by 16, divided by that base font size, will give you the rem value that you want. And that means you can take that simple calculation and perform it for whatever pixel value you want to end up with. So, for example, 32 pixels divided by 16, the base font size, would give you 2 rems. So wherever you use 2 rems, you'll get an approximation of 32 pixels, or something a little bit less round, 50 pixels divided by 16, 3.125 rem. And the smallest value that you're going to be working with, 1 pixel divided by 16 pixels, is 0.0625 rem. Now it's this basic calculation, the target pixel size divided by the base font size, that we're going to create a little stylus variable to handle for you. You've already seen in the previous video how to declare a variable. Now the first thing that we're going to put in place is a variable to hold our base font size. We know that, generally speaking, the base font size is 16. Now all we have to do is replicate this little calculation that you see over here. Now the way I'm going to do that is first by creating a little variable called px, and then I'm going to say px is equal to 1 divided by, make a space actually, this base font size. Now that right there is the same calculation as this. Because once you know the size of a single pixel, all you have to do is multiply that out by as many pixels as you need. And you'll see that in practice shortly. If that doesn't make sense yet, don't worry about it. You'll see it working in just a moment. Now we have the maths done, but the other thing that we need to do is also attach the actual rem the letters themselves that you need to have output in your CSS to make this work. So I am going to just wrap this little equation in brackets so that it gets performed first before anything else happens. And then I'm just going to finish up by typing rem. Now we have our pixel value. So how do you use this? Let me show you. In this second demonstration, we've got a basic, content and sidebar, fairly standard layout. We are going to apply our px to rem variable to this part of the demonstration and leave this one as a fixed pixel layout. Now, applying the variable is really, really easy. Now, at the moment, this code is the same as this code. So this second rem class here will be affecting this top layout up here. Now all you need to do is write out your code just like you always would, but instead of just writing a pixel unit on the end of the number that you're working with, you just multiply with the little star symbol by your variable. Save and compile. You can see that nothing changed. That's exactly what we want, because we still are trying to have a layout that appears at the same size as it would if you were using those fixed width and fixed height pixel values. I'm just going to go through and do the same thing with the other values. You don't actually need these spaces. I just wanted to put those in to make it a bit clearer to you what the syntax was. So basically, you're just adding star $, star $, star $, star $. Now, still, this looks exactly the same. At first, it looks the same as long as you have that default font setting of 16 pixels. However, if you have a look at the CSS that has been generated, you'll see that the rem class is now all done in rem values. You see down here as well. While the pixel class is still using its fixed pixel values. Now this makes a big difference when you start to see that settings change like we saw earlier. Now if I increase the font size, I'll just make this full screen so you can see it a little bit easier. Now you can see that even though the font size has changed here and here, only the rem-based layout has increased in size proportionally. And this also works downscaling as well as upscaling. Again, you can see everything in the rem-based value has shrunk proportionally. You can also notice that that includes the width of the borders and the curvature on the border radius here, the whole thing. So by using this px to rem variable instead of just straight pixel units, you get the best of both worlds. You can still think about your design in exactly the same way, but at the end of the compilation process, your whole design is scalable. Again, just going back to our code, all you need to do is just include that little star and the $sign from your variable name. And that's it. It's that simple. All right, that's it for your practical introduction to variables. You've learned some really simple but really useful ways to start getting into working with Stylus variables. In the next section, Practical Intro to Mix-ins, you're going to learn about another one of Stylus's really, really awesome features. And we're going to kick off with showing you how to use mix-ins by creating a zebra striping mix-in. And that will let you apply zebra striping to the children of any element with a single line of code. Catch you then.